Hi there, I'm Dr. Joel Hunter, and today we are going to be talking about your eye and specifically the floaters in your vision that you sometimes see. Now, perhaps there's been a time where you were staring out of a car window into a bright, blank, blue sky, or maybe there was a time where you were looking at your computer screen and it was just a white background and you saw something, but it wasn't in the sky, it wasn't in the computer screen. That thing you saw actually was in your eye. You didn't know that at first because you kind of reached for it or you looked to see where it was coming from, but it moves with your eye. Matter of fact, it's got some inertia. It's almost like an amoeba that's just floating. And if you're unlucky, it's just in the center of your vision, and every time you try to get a little closer, it floats a little bit farther away. That is called a floater. And there's a reason that you can see it better on a very uniform background. There's a reason that you can see it better on a background that's blue, like a blue sky. So what are floaters? It's one of the most common eye conditions that people have, and it's one of the most annoying ones that people have. And they often wonder, does this mean something's wrong with my eye? Rarely, yeah, it does. But in those cases, it's usually pretty obvious because there'll be a shower of new floaters. It'll look like somebody released confetti inside your eye, or there's a bunch of sea monkeys swimming around in there. The general run-of-the-mill floater, which is usually just a single little worm or little amoeba floating around, it's much more common and it's much more benign. And that's because it's not a worm, it's not an amoeba, it's actually part of the makeup of the inside of your eye. So if we were to draw an eye from the side, it would look a little bit like this. So if we were turning to the side, on the front of your eye there's this dome, that's the cornea. And then if you go a little further back, there's the colored part of your eye, the iris, a pupil in the middle. There's a lens inside your eye right here that's just called the lens. But about 75% of your eye is made up of all of this right here. This whole body here is called your vitreous humor. Now the vitreous is interesting because it's not recycled like the stuff in the front of your eye is. Up here in the front of your eye, in this part we call the anterior chamber, that line doesn't exist in the eye, that's why we erased it. But in the anterior chamber, which is basically from here to here, this stuff is called the aqueous. And what's interesting about the aqueous is about every hour and a half you have brand new aqueous. It's always new, filtered, coming in, coming out. It's basically like really, really nice saline with some extra electrolytes added inside. But the vitreous, this vitreous gel, this vitreous body back here, what you're born with is what you will die with someday. It stays the same throughout your entire life. And what's interesting about the gel is that when you're a kid, when you're 1, 2, 3 years old, that vitreous gel is dense. It's got body to it. It's kind of like Jell-O. Like if you took Jell-O out of the fridge and let it sit for 10 minutes. It's wiggly if you were to lay it on a table. This vitreous, when you're a kid, is like that. And it's because it's got this nice evenly spaced protein and it's got this nice evenly spaced macromolecules. So it stays transparent, but it's got body to it because that's what gelatin is. Even Jell-O is. It just tastes a lot better than this would, probably. I've never had vitreous. So when you're having floaters, it's because the vitreous gel has aged over time. And what happens when it ages is that it will slowly liquefy in little pockets. The areas where those proteins were evenly spaced, where those macromolecules were elegantly, precisely spaced away from each other, they will start to collapse. And when those places collapse, some water will fill up that pocket where they were. And so it might look a little bit like this. That is some evenly spaced protein and macromolecule structure. But what happens if you were to have a water pocket form right by there? Well, I'll show you. This would be the water pocket, and these would be those little proteins that you saw hanging evenly spaced before. What happens is they get disorganized, they clump up, and so that spot that used to be completely transparent, now there's this little clump of protein floating. But the rest of your vitreous gel still is in gel form. It's still like Jell-O. So it just floats there. It doesn't have anywhere to go. It's suspended, like if you were to imagine a fly in the middle of it, of some Jell-O, it doesn't have anywhere to go at all. Or maybe a pineapple. That's less gross. They put pineapples in Jell-O sometimes. That's what that's like. It's just floating there. And the reason there's inertia is because the rest of the gel moves and wiggles with your eye as you move your eye around, but this is stuck in there. And so if you have a floater that's right in the middle of your vision, as light is coming into your eye, it's coming and it's hitting that floater, and what happens is, let's draw a light beam, it is casting a shadow. It's a lot like if you had shadow puppets on a wall, because the light that was coming in, this light ray gets blocked. It gets dispersed by that floater. The ones around it, they make it right through. And what that means is you're gonna see that thing inside your eye. Now, as a bonus factoid, the reason that you see the ones in blue light more is because blue light has a shorter wavelength of light. And so blue light gets focused a little bit farther forward in front of your retina. And so the shadow that gets casted by floaters is a little bit sharper, and you can see it. Now what happens to floaters over time? Well, given enough time, the vitreous will slowly liquefy all the way. It gets waterier and waterier over time until all of these floaters are generally succumb to gravity and fall down to the bottom of your eye. But for floaters that are very, very annoying, sometimes you can actually have them shot by a laser. As weird as that sounds, it's called a YAG vitreolysis. That procedure can be done, but you want to go to somebody who really knows what they're doing and not somebody who just has a new laser that they want to use. All that to say, floaters are generally harmless and they're pretty annoying. Hope that helps.